What's up, everybody? This is the Helpful Hacker. Today, we're going to be going over the OSI model room from TryHackMe. So let's get started with task number 1. What is the OSI model? So the OSI model, that stands for Open Systems Interconnection Model. And that's just a model that describes how devices communicate on a network. That's all you need to remember. So this is the ideal model of how one device would communicate with another on the network. So that's the big thing you got to know. And then you got to know that there's 7 layers to this model, right? And they're listed right here for you. And additionally, you'll want to know about encapsulation, which is just where data gets more data added to it, right? And I think of like, those pills that have the 2 caps, and then on the inside is like a dusty material or whatever, and they cap it off. So that's encapsulation. So you can think of your layer 1 as like the actual medication, and then layer 2 is going to be that first encapsulation. And then as you move up the layers, you're going to keep encapsulating that first layer. But every time you encapsulate, you're going to add a little something to it. So hopefully that made some sense. That's encapsulation. Like I said, I like to visualize like one of those little hills where you can clearly see it's like the 2 ends that have been smashed together in the little capsules. If that doesn't work for you or you don't know what I'm talking about, then just know that encapsulation is where each layer we're going to add a little data. And then if it's going through the other way, at each layer, we're gonna remove a little bit of data, depending on how the information is flowing. So yeah, with that, you should be able to answer these last three questions at the bottom. What does OSI stand for? Open Systems Interconnection. And then how many layers are there? 7. What's a key term for when pieces of information get added to data? Encapsulation. Hopefully my example helped. If it didn't at all, then just pay attention to this question and that answer. Okay, so go through that, answer the questions, read all of it, and then you're done with task 1. Task 2 is layer 7. And when you think about layer 7, I want you to think about GUI, or graphical user interface, right? You can read about what that is right there. Go through, read this. But that's what I want you to think about. This is an entry-level room, so it's not like you need to understand all these in great detail and be a master of each layer. But just when you think of layer 7, I want you to think of graphical user interface. And if you don't know what that is, that's something like this. This would be the graphical user interface for a file system, right? Or you can think of like an email, right? When you log into your email and the thing comes up and you have the prompt and you can type a new message or whatever, everything you're seeing there, that's the graphical user interface for your email. So hopefully that helps. So go through that, answer the questions. The name of this layer, application, technical term given to the name of the software that users interact with, graphical user interface. So go through that, and then you're done with task 2. Task 3, which is layer 6, or the presentation layer. When you think of this layer, I want you to think of translator, okay? Because what 6 is mostly in charge of is basically translating data from layer 5 to something that is usable in layer 7, and then vice versa. If the data is going from layer 7 down, then layer 6 is going to be in charge of converting it into something that layer 5 can actually use so that it will actually understand the data. So yeah, think of translator when you think of layer 6. We could go into more detail about layer 6, but it's not super important for this room. If you want to know more about it, you can Google it. There's lots of good examples about what layer 6 does and how it works. So go through. I almost forgot. Answer the questions at the bottom. Presentation layer, the main purpose, it acts as the translator. Answer those, and then you're done with task 3. So task 4, the session layer. So the session layer, it's named perfectly because what it's going to do is it's going to be in charge of starting sessions, ending sessions, making sure that when two computers are speaking that they're synchronized, right? And it's going to have everything to do with the session, okay? So that's what you can think of. And it says right here, it will begin to create a connection to the other computer that the data is destined for. When a connection is established, a session is created. Whilst this connection is active, so is the session. Okay, so layer 5, that's got everything to do with the session. It's in charge of the session, when it starts, when it ends, and making sure everything syncs up. So then you can go through these questions. Pretty straightforward. And then at the end, what is the technical term for a small chunk of data? That is called a packet. And we're going to get more into packets a little bit later. There's a whole nother room after this on packets and frames. At least I think that's what it's called. But yeah, for now, just know that a packet is a small chunk of data. And then later we'll start referring to packets. So once you've answered those questions, you finished task 4 or layer 5, the session layer. Now it's on to task 5 or layer 4, the transport layer. Now, when you think of the transport layer, I want you to think of two things, TCP and UDP. We're going to talk about both of them, and I'm going to explain what they are. So TCP stands for Transmission Control Protocol. And what this is this is a form of communication between devices in which TCP is working very hard to guarantee the accuracy of what it's sending. It synchronizes the two devices so that they don't, get messed up or get incorrect information or information at the wrong time. And it makes sure that everything got to where it was supposed to go. So the big advantages of TCP, to sum it up, is basically TCP makes sure that information gets to where it's supposed to go in the right order, and that the other person at the other end got it and was able to understand it. Now, the disadvantage of this is because it takes so much time guaranteeing this accuracy, it's a lot slower, right? So it's not as quick of a connection. So just keep that in mind. And now what I think will really solidify your understanding of TCP is this example right here. So we also talked about packets, which are just small pieces of data. So when we start sending data to another device on a network, we can't just send all of it at once. That would be super inefficient. So what we tend to do is, with TCP anyways, is we tend to break that up into really small bits of data, and those are called packets. And then TCP sends over all these packets, and at the end, the other computer is able to reassemble them and get all of the data that we sent. So here in this example, you have little pieces of the cat. We send them out in little pieces, and then the other computer is able to assemble it at the end. So what TCP does is it makes sure each one of these packets got to where it was going. It makes sure that the packets are labeled correctly, that this packet is labeled 1, this is labeled 2, this is labeled 3, so that the other computer can assemble it properly. So because of that, it's a little slower. Now, UDP. UDP is basically like the opposite of TCP. You can think of them as brothers. The advantages of UDP is it's super fast, right? It doesn't care if the other computer gets all of the data, and it doesn't have to maintain. Right here it says does not reserve a continuous connection on a device, right? Because UDP is just not worried. It's just going to do its best to send all of the data it can as quickly as possible, and what gets to the other computer gets to the other computer, and that's that. So that's UDP in a nutshell. So the disadvantages, like we already talked about, it doesn't care if the data gets received, and stuff like that. It's an unstable connection, right? And so let's go down to this example here. So as we can see, now we're going to send the cat, but we're going to use UDP. So we're going to send packet 1, packet 2, and packet 3. Well, what happened? Packet 2 got lost, right? So when the computer over here tries to assemble this data, it's going to have a imperfect picture. It's not accurate. You're missing a third of the cat. And so that's kind of the problem with UDP, right? But again, the advantage is it's way fast. So for example, if you're video streaming something, right? You don't care about every single pixel being perfectly in place and perfectly in color, right? You could, but then to do a live stream would take forever. But you can use UDP because UDP is super fast. And for the most part, if a handful of pixels are missing or discolored, that doesn't matter. So when you think of UDP, I want you to think of like FaceTime or live stream or something that requires a lot of data to be sent quickly. And it's not important if every single bit of data is perfect. Whereas TCP, I want you to think of like email. It's important that every bit of data is right in an email, or else you could accidentally be missing important words or, important value. So those are kind of the two things I want you to think of when you think of this transport layer. Super important layer. Got to know it pretty well. So you got to know TCP, you got to know UDP, you got to know what they stand for, and you got to know some of the advantages and disadvantages and kind of how they work, right? So read through that. Hopefully my examples helped. These diagrams are great, so pay attention to those. And then let's answer some questions. So the name of this layer, layer 4, is the transport layer. TCP stands for Transmission Control Protocol. The control, right? So just think, how does it work? It works by knowing where everything is, making sure things happen. So TCP, right? It's on top of it. It makes sure everything gets to where it's supposed to go. Then you have UDP, User Datagram Protocol. It does not care. It just sends data as quickly as and as best as it can. So TCP is going to guarantee the accuracy of the data. UDP, like we said, doesn't care. What protocol would an application such as an email client use? TCP, right? Because you want to make sure everything's accurate. What protocol would an application that downloads files use? So that would also be TCP. And that's because if you aren't downloading the whole file or like a whole picture, let's say, and you're missing a big chunk of it, that's not helpful. And then you just have to re-download it anyways. So something like that is going to use TCP. And then what protocol would an application that streams videos use? UDP, right? Like we said, think FaceTime, right? Or Skype. Those are all using UDP because it's happening real time. It has to happen quickly, and it can't waste its time worrying about whether or not the person on the other end got everything perfectly. As long as it got most of it, that'll work. So go through, answer those. And once you've done that, you're done with task 5, the transport layer or layer 4. And then you can move on to task 6, which is layer 3, the network layer. So network layer, when you see this layer, I want you to think routing. That's what I want you to think of routers. I want you to think of routing, right? Because this is where routing happens and the reassembly takes place, right? And this is where the other computer is going to take these small chunks and, add them up into the large chunks. So yeah, a couple of protocols associated with this layer are open shortest path first and routing information protocol. Both of those have to do with routing and how you would send data, over the internet or over multiple networks to its destination. So yeah, pretty cool, important layer. It's pretty straightforward. One other thing to note about this layer is this layer deals with IP addresses, right? So everything they're doing at this layer 3, this network layer, you're talking IP addresses. And this is going to be doing routing. Okay, so that's what I want you to think of. Layer 3, think of IP addresses, think of routing, and that's the network layer. So read that. We're going to go through, answer the questions. What is the name of this layer? Network. Will packets take the most optimal route across a network? Yes, that's what the whole routing thing is for. It's to, make things efficient and make sure things take the best route possible. OSPF, that's a protocol, and it stands for Open Shortest Path First. And then RIP, also a protocol in this layer, stands for Routing Information Protocol. And then what type of addresses are dealt with at this layer? IP addresses, right? So keep that all in mind. That's layer 3. Once you've answered all those, you're done with that, and it's on to task 7 or layer 2, which is the data link layer. So the data link layer, when you hear that, I want you to think MAC address. That's what I want you to think of. So that's pretty much the major point to this whole layer is this is dealing with MAC addresses. So it's going to take the packet from the network layer with the IP address, and it's going to add the MAC address to it, right? And we've talked about MAC addresses before. In case you didn't watch the previous videos in this series, basically, MAC address, a MAC address is just a number that's a unique identifier, and it's burned onto something called a network interface card. And that's made by the manufacturer, and they literally burn it into the card, like it says right there. And this network interface card is what allows a device to connect to a network. So any network connected device has a network interface card, and that network interface card has a MAC address most likely burnt into the side of it. So that's what a MAC address is. That's what the data link layer does. It worries about the MAC address and getting that on there and making sure that we know exactly which computer all this stuff is going to. So that's layer 2. Then answer the questions. Name of this layer, data link. What is the name of the piece of hardware that all networked devices come with? Network interface card, like we talked about, right up there. So answer that. You're done with task 7. Now we're on to task 8, the physical layer. When you think of, task 8, layer 1, sorry. You got to remember the layers, not the task number. So layer 2 is data link. Layer 1 is the physical layer. And I want you to think of ones and zeros. This is the actual ones and zeros, the bits and bytes of data being sent. So yeah, and it talks about that, gives you a quick example, talks about Ethernet cables. So read through that, super short, answer the questions. So this is the physical layer. The numbering system, so the ones and zeros, that's binary, and that's what it's sending over an Ethernet cable. And then you have, of course, Ethernet cables are the cables that connect devices. Unless you're doing it wirelessly, then you don't need an Ethernet cable, but not important right now. So go through that, answer those, then task 8 is done. That's layer 1. Then you have task 9, which is this game. And basically the point of this game is to just help you remember the different layers of the OSI model, right? So physical, data, network, transport, session, presentation, application. So we're going to play it and see how good I know these. I assume you start at layer 1, right? Yeah, okay. So first is going to be the physical, and then the data link, and then network. By the way, you should be able to do this without really thinking about it. That's how well you should have these memorized. So then transport, then session, then presentation, and then last is application. And then once you do that, you'll get this flag right here. And you can just copy that flag, paste it down at the bottom, and then submit that as the correct answer. And with that, you're done with task 9. And then task 10, continue your learning, go learn about packets and frames. I have a video explaining that room as well. If you found this video or any of my other videos helpful, you should give this video a like and subscribe. That helps me out a lot. And once you've gone through all this, click correct answer. You've finished task 10. And once you've finished task 10, you have finished the OSI model room from TryHackMe.